Hi everybody, this video is going to walk through questions number 4 and 5 on page 73 of your packet. So these are the two examples for the intermediate value theorem that we did not get to cover in class on Thursday. So I just wanted to give you a video walking through those so that you can use these as references when you're doing your practice, as there are some similar problems in your practice. Okay, so number 4 says to consider the continuous function f of x in the table below. If the intermediate value theorem can be applied on the interval from -4 to 4, so that's the same interval that we have kind of covered in our table here, what is the minimum number of zeros for the function on the interval, right? So again, zeros, right? Different ways of saying that. We have zeros, again, just to do quick vocabulary. Zeros is the same as the roots. We can also think about it as the x-intercepts, right? Places where our function is equal to 0. And so we're looking for the minimum number of zeros for the function on this interval. And it's really important here. They've told us that this function is continuous. So we know there's no holes or jumps. We know that all these kind of points in between what we see in our table are all connected really smoothly. So I'm going to show you two methods to kind of approach this problem. The first is just using the data in the table to kind of intuitively determine where we at least know that we have roots, right? It says IVT does apply here, so we can guarantee some number of roots. So if I'm looking for a y value of 0. In the table here, I see I went from -2 to +1. So it must be that somewhere in between there, since I'm continuous, I passed through f of x equals 0. So there's one place. Here we can see clearly in the table that we have a 0. And then if I look here, I went from 1 to -2, tells me I must have crossed through 0. So I can see here that I have at least 3 zeros here. I don't know what else might have been going on, but there's at least 3 places that I must have zeros. Now, for those of us who are a little more visual, which tends to be me most of the time, another way we could approach this is just to sketch a quick graph. A lot of times, sketching a graph is going to be a great method to help us visualize what's going on. So I'm going to sketch out the points that I've given here. Let's see, down to -2 and 1. So I've got the point -4, -2. I've got the point -2, 1, 0, 0, 2, 1, and 4, -2. Now, I don't know exactly what this curve looks like, but it doesn't matter. Since it's continuous, I can sketch in. Oh my gosh, I'm so sorry about this. One of these days I'll figure that out. I can sketch in some curve that just connects these points. I know it's continuous, so there's no holes or jumps or anything going on. So then I can see in my picture, there's at least 3 places here, here, and here where I'm crossing the x-axis. And so this visual kind of representation gives me the same result. We know we can guarantee at least 3 zeros for this particular function on the given interval. Okay, number 5, we've got g of x. Again, they've told us it's continuous. They said selected values of y equals g of x are given in the table below. It wants to know for which value of k will the equation g of x equals 1 have at least 2 solutions on the closed interval from -2 to 8. So this one's a little harder to just get the answer from the table. So I'm definitely going to sketch a picture here, sketch a graph of what I know. So let's see, we're going up to 8. And it looks like my highest y value that I know is 5. All right, so let's sketch in the points we know. We've got 2, 3, 3, 4. 4, I'm not quite sure what's happening there. 5 has a y value of 5, and then 8 has a y value of 2. So let's see what we know. Since this is continuous, I can connect these points here. I'm going to make a little kind of line here because I'm not sure what's going on at 4. So I'm not going to connect anything up there yet. And then I can connect these. And the idea is I want to know the values of k for which the equation g of x equals 1 will have at least 2 solutions. Well, for it to have 2 solutions, I'm going to make a note here that my function, then my graph, must cross g of x equals 1 at least 2 times. That's what we mean when we say this has to have at least 2 times. That's what we mean when we say it must have at least 2 solutions. So I'm just going to sketch in here g of x equals 1, right? That's saying y equals 1. So I need to find this value of k so that if I were to connect up my graph here, I'm going to cross that pink line at least 2 times. So let's test out the values. The first one says, well, let's make k 0. So my ordered pair would be 4, 0. Now, if I were to connect up my graph here, my continuous function, we can see that when k is 0, we actually do cross this pink line twice. So that's going to be our answer here. The value of k will be 0. Now, really quickly, we should always test out the others to make sure we haven't made a mistake. So I'm going to do that really quickly. Let's see what would happen if we picked the point 4, 1. Well, in this case, we can see we would only touch g of x equals 1 once. So that would not satisfy our condition of having at least 2 solutions. And then anything above 1, so let's say we picked k was 2, you can see for that, we're not even going to hit that pink line. So 0 then is the correct choice for this question. All right, so I hope that's helpful to you in completing the homework problems. We will start off when we're back in class on Tuesday by going through the homework and any questions that you had. All right, thanks for watching, and I'll see you back in class.